February 25, 1945. 14:30 hours. Motoyama Airfield No. 1, Iwo Jima. The air does not just smell like sulfur, it tastes like copper. It tastes like pulverized rock. It tastes like vaporized steel. A machinist's mate of the 133rd Naval Construction Battalion stands at the edge of the southern runway. His boots sink 3 inches into the black, unforgiving volcanic ash. He does not look up at the sky. He looks down at the dirt. The dirt is the enemy. Before him lies a catastrophic expanse of ruin. It is a pulverized stretch of black sand, choked with the twisted skeletal remains of destroyed Japanese bombers. The runway is pockmarked with blast craters, some 30 feet wide and 10 feet deep, voids large enough to swallow a Sherman tank whole. Unexploded ordnance litters the ground like deadly metallic seeds. This is not an airfield. It is a lunar wasteland. It is a slaughterhouse. From Mount Suribachi to the south and the jagged Motoyama Plateau to the north, Japanese artillery has this exact strip of land zeroed in. Every square yard has been pre-calculated, mathematically dialed into the sights of hidden mortars and heavy guns. When a Seabee steps onto the tarmac, he steps onto a geometric grid of death. The paradox is absolute. To survive the island, the United States Marines need close air support, casualty evacuation, and fighter cover. To get that cover, this airstrip must be operational. But to make it operational, men must drive unarmored yellow bulldozers into the crosshairs of the most heavily fortified fortress in the Pacific Ocean. An engineering miracle must emerge from total apocalyptic destruction. The machinist's mate climbs into the steel seat of his D8 Caterpillar bulldozer. The engine turns over. It catches. It roars. It is a mechanical challenge thrown into the teeth of an entrenched enemy. He pushes the blade down. The ash resists. It demands blood. It demands sweat. It demands diesel. Lieutenant General Tadamichi Kuribayashi, the brilliant commander of the Japanese garrison, has made a calculation. He looks at this shattered runway and sees an impenetrable puzzle. He calculates the cubic yardage of displaced earth. He calculates the tonnage of the craters. He calculates the kill zones of his artillery. His mathematics tell him that no military force on Earth could repair this airstrip under sustained fire. He assumes the Americans will be bogged down for weeks, their logistics strangled, their aircraft permanently grounded. He believes the island's geology and his pre-planned destruction are his ultimate weapons. He is wrong. He has factored in the volcanic rock. He has factored in the artillery. He has not factored in the American Seabee. He has not factored in blue-collar men who build airstrips with an M1 Garand slung over their shoulder and a heavy wrench in their hand. The Japanese have designed a masterclass in delay. The Seabees are about to deliver a masterclass in violence and velocity. But before we watch these bulldozers push back the very gates of hell under a rain of artillery, hit that subscribe button and leave a like. In documentaries like this, we strip away the myth and look at the raw, bleeding edge of logistics. Help us keep bringing you the hard truth. We are diving straight back into the black ash of Motoyama. The bulldozer pushes forward. The first load of ash fills a crater. A mortar shell detonates 50 yards away. Shrapnel clinks against the steel dozer blade. The operator does not flinch. He shifts gears. The heavy tracks grind over the volcanic earth. The clock is ticking. The Marines are dying. The runway must be leveled. Not next month, not next week. Today. The impossible problem has been assigned. The violent solution has begun. 1,500 miles of hostile, open ocean separates the American bomber bases in the Mariana Islands from the industrial heart of the Japanese home islands. In geographical terms, this is roughly the distance from New York City to Denver, Colorado, stretched entirely across a featureless, unforgiving blue desert. Every strategic bombing mission requires a 3,000-mile round trip. For the crews of the 20th Air Force, the vastness of the Pacific Ocean is as lethal and as merciless as the enemy anti-aircraft batteries. The weapon of choice for this campaign is the Boeing B-29 Superfortress. A fully loaded B-29 weighs 133,000 pounds. That is the combined mass of two fully armored M4 Sherman tanks lifted into the stratosphere and hurtling through the thin air at 300 miles per hour. It carries thousands of gallons of highly volatile aviation fuel and up to 20,000 pounds of high explosives. It is an industrial marvel of the 20th century. It is also a fragile, pressurized aluminum tube driven by four massive Wright R3350 radial engines notoriously prone to overheating, catching fire, and catastrophic failure. When a B-29 takes heavy flak over Tokyo or suffers a mechanical failure over Nagoya, the pilot faces a brutal mathematical reality. A crippled bomber, leaking fuel from a punctured wing tank or running violently on 3 damaged engines, cannot physically survive the 1,500-mile return journey. It will run dry. It will descend. It will ditch into the cold, churning swells of the Pacific. The aircraft will shatter upon impact with the water. The crew will drown in the dark. Hundreds of millions of dollars in aviation technology and thousands of highly trained, irreplaceable aviators are quietly bleeding into the sea. Furthermore, the heavy bombers fly naked. The North American P-51 Mustang, the premier American fighter aircraft, has a maximum combat radius of barely 750 miles. It cannot shepherd the heavy bombers all the way to Tokyo and back. Without fighter cover, the B-29 formations are consistently ripped apart by nimble Japanese Zeros and twin-engine interceptors. The American strategic bombing campaign is stalling. It is losing momentum. It is bleeding out over the ocean. The solution to this crisis is not tactical. The solution is strictly geographic. Look at the navigational charts of the Pacific Theater. Exactly halfway between the Marianas bomber bases and the sprawling factories of Japan lies a solitary 8-square-mile extrusion of volcanic rock. Iwo Jima. It is an ugly, sulfur-venting island shaped roughly like a mangled pork chop. It boasts no indigenous population, no natural sources of fresh water, and no resources of any civilian value. Yet, in the brutal calculus of the Pacific War, it is the most valuable piece of real estate on planet Earth. If the United States military can capture and control Iwo Jima, the strategic paradigm flips instantly. P-51 Mustangs can base there, extending their lethal umbrella of protection directly over the Japanese capital. Crippled B-29s bleeding oil and altitude can use it as an emergency landing strip, saving hundreds of bombers and thousands of American lives. It is an unsinkable aircraft carrier anchored in the Philippine Sea. It is an emergency ward for dying machines. It is the geographic linchpin required to burn the Japanese war machine to ash. Lieutenant General Tadamichi Kuribayashi, the brilliant, aristocratic commander of the 109th Division of the Imperial Japanese Army, understands this geographic reality with absolute crystal clarity. He knows the Americans are coming. He knows exactly why they are coming. And he knows with grim certainty that he cannot win. The United States Navy surrounds the island with an impenetrable steel armada. The skies above belong entirely to American aircraft. Kuribayashi is permanently cut off from the empire. Resupply is impossible. Reinforcement is a fantasy. For all strategic intents and purposes, his garrison of 21,000 men is already dead. But his objective is not victory. His objective is time. He must delay the inevitable invasion of the Japanese home islands, and he will use the airfields of Iwo Jima as his primary mechanism of friction. Kuribayashi fundamentally alters Japanese defensive doctrine. Traditionally, Imperial forces met the enemy right at the waterline, attempting to repel amphibious assaults in massive, bloody banzai charges. Kuribayashi strictly forbids this. He looks at the island's dominant topographical features, the 550-foot dormant volcano of Mount Suribachi to the south, and the jagged, treacherous Motoyama Plateau to the north. Between these two imposing high points lies the relatively flat black sand saddle of the island. This flat saddle is where the airfields are located. Motoyama Airfield Number 1. Motoyama Airfield Number 2. An unfinished runway designated Airfield Number 3. Kuribayashi recognizes a fundamental truth. The Americans do not want the caves, they do not want the cliffs, and they do not care about the sulfur vents. They only want the flat ground. They want the runways. So, he gives the flat ground to them. He turns the entire island into a defensive masterpiece designed exclusively for maximum attrition. His engineers dig 11 miles of interconnected subterranean tunnels, blasting and scraping through solid volcanic basalt. They build a vast subterranean city of command posts, ammunition bunkers, and artillery emplacements. This underground empire is virtually impervious to the heaviest naval bombardment and the heaviest aerial bombs. He pulls all of his heavy weapons back into the high ground. He places 150mm howitzers, rapid-fire anti-aircraft guns, and massive 320mm spigot mortars, terrifying weapons launching explosive projectiles weighing 675 pounds, the equivalent mass of a grand piano packed with high explosives, into heavily fortified camouflaged caves. Every single weapon is meticulously sighted. The artillerymen do not need to aim. They simply dial in pre-calculated coordinates, and every single coordinate converges directly onto the airfields. The runways form the bottom of a massive, heavily armed bowl. It is a textbook kill zone. Kuribayashi's grand strategic plan relies on an ironclad assumption regarding the limits of heavy civil engineering. He intimately knows the sheer kinetic force involved in landing a heavy bomber. When a B-29's landing gear slams onto a runway, it delivers a localized shock equivalent to dropping a locomotive straight down onto the tarmac. If the runway is unstable, if a crater is improperly filled with loose ash, the landing gear will catch. It will shear off entirely. The 133,000-pound aircraft will violently cartwheel. The aviation fuel will vaporize and detonate. A structurally compromised runway is just as deadly to an American bomber as a squadron of Japanese fighter planes. To repair an airfield to the rigorous, uncompromising specifications required for heavy, four-engine bombers, an engineering force requires a secure perimeter. They require massive quantities of crushed rock, asphalt, and chemical binders. They require heavy diesel rollers moving in slow, predictable, geometric patterns to perfectly compress the subgrade. They require time, and they require safety. Kuribayashi calculates the cubic yardage of earth his heavy artillery can displace per hour. He measures this against the top speed of American bulldozers. He factors in the extreme vulnerability of unarmored heavy equipment. A single shrapnel shard piercing a high-pressure hydraulic line immobilizes a tractor instantly. A mortar shell hitting a fuel bowser creates a localized, uncontrollable firestorm. A sniper bullet through the glass windshield of a grader permanently eliminates the highly trained operator. The Japanese commander mathematically deduces that no military force can conduct precision civil engineering under an unceasing, perfectly dialed-in barrage of heavy artillery. He calculates that the Marines will capture the airfields, but the engineers will not be able to utilize them. He envisions the American construction battalions bogged down for months, attempting to fill blast craters during the day, only to have them violently blown open again at night. He believes he can bleed the American logistics chain dry. keep the P-51 escorts permanently grounded, and ensure the B-29 superfortresses continue to drown in the deep waters of the Pacific. He relies on the absolute, undeniable logic that soft human flesh and unarmored steel cannot perform delicate construction tasks inside a heavily targeted slaughterhouse. This is his masterstroke. It is a perfectly reasoned, logically sound, strategically brilliant assumption. And it is completely, violently wrong. The black ash of Motoyama No. 1 does not behave like earth. It behaves like dry water. A heavy equipment operator from the 133rd Naval Construction Battalion sits in the exposed steel saddle of his grader. He grips the hydraulic levers. His hands are blistered, wrapped in oil-stained canvas gloves. He stares at the ground. He does not look at the geysers of sand erupting from Japanese mortar strikes 300 yards to his left. He tells himself to keep the blade steady. He calculates the angle of the cutting edge. He forces his mind into the geometry of the grade. The immediate obstacle is not the Japanese infantry. The immediate obstacle is the geology of the island itself. Iwo Jima is an active volcanic extrusion. The ground is a loose, granular pumice. It possesses zero cohesion. To build a runway capable of supporting the localized impact of a landing bomber, an engineer needs dirt that binds. They need aggregate that locks together under pressure. This volcanic sand simply displaces. When a 30,000-pound bulldozer, the mass of a fully loaded city bus, tracks over it, the sand simply shifts, swallows the steel treads, and grinds away at the drive sprockets. The environment is aggressively, chemically hostile. The island bleeds sulfur. Fissures in the crust vent highly toxic, yellow gas that strips the lining from a man's throat and burns the moisture from his corneas. The ambient air temperature is 95 degrees Fahrenheit. The ground temperature is worse. 2 feet below the surface, the volcanic soil reaches temperatures of 140 degrees. It is hot enough to blister exposed skin. It is hot enough to melt the rubber soles of combat boots. These are not traditional infantrymen facing this nightmare. They are Seabees. They are the blue-collar backbone of the American industrial war machine. Before the war, they were Appalachian coal miners. They were Texan wildcatters. They were structural steelworkers from Chicago and highway graders from the Pacific Northwest. The United States military did not teach these men how to build. It only taught them how to shoot. They are men in their 30s and 40s, men with receding hairlines and thick, calloused hands, carrying the pragmatic, uncompromising stubbornness of the American working class into a kill zone. They look at the shattered expanse of Motoyama Airfield No. 1. They see an engineering puzzle smeared with blood. They break the impossible problem down into brutal, sequential steps. Step 1 is the subtraction of the explosives. Before the earth can be moved, it must be disarmed. The runway is littered with thousands of pounds of unexploded ordnance. Naval bombardment shells that failed to detonate. Japanese anti-tank mines buried in the loose ash. Cluster bomblets lying half-submerged. Explosive ordnance disposal teams crawl on their bellies over the hot, abrasive pumice. They use bayonets to gently probe the loose sand. They do not wear armor. Armor slows a man down. Armor restricts the fine motor control of the fingers. They locate a buried 500-pound aerial bomb, a steel cylinder carrying enough high explosive to vaporize a 2-story residential home. They meticulously dig around the casing with their bare hands. They unscrew the rusted, sand-jammed fuses. They sweat. They breathe the sulfur. They drag the neutralized steel away. They move to the next. The work is perfectly binary. A man is either successful or he is entirely erased from the physical world. Step 2 is the mathematical correction of the terrain. The runway is dominated by blast craters. A standard naval shell crater on Motoyama is 40 feet wide and 15 feet deep. It is a massive concavity that must be erased. The heavy equipment operators move in. They drive unarmored Caterpillar D8 bulldozers. They have scavenged sheets of boilerplate from destroyed landing craft and welded them around the engine compartments to protect the vital hydraulic lines from shrapnel. They have not protected themselves. They must see the blade. They must feel the grade. The operator pushes a mound of black ash toward the crater. The diesel engine screams, fighting the lack of traction. Black exhaust belches into the humid air. The bulldozer hits the lip of the crater and tilts forward. The operator throws the clutch, drops the heavy steel blade, and shears a cubic yard of earth into the void. A cubic yard of this volcanic ash weighs roughly 2,000 pounds, the equivalent mass of a heavy draft horse. He reverses. He shifts. He pushes again. But filling the crater is only a fraction of the solution. If loose ash is simply dumped into a hole, it remains a soft sponge. If a bomber tire hits that soft spot at 100 miles per hour, the landing gear will instantly snap. The earth must be compacted. This requires the brutal, repetitive application of the 6-inch lift. The bulldozer pushes 6 inches of dirt into the crater. Then the heavy steel drum rollers must drive over it, crushing the air out of the soil. Then the bulldozer pushes another 6 inches. Then the roller returns. It is a slow, agonizing waltz of heavy machinery. And it is being performed in plain sight of Japanese forward observers. The enemy artillery adjusts. A 150-millimeter howitzer shell shrieks out of the northern plateau. It detonates 70 yards from the grading operation. A cloud of jagged steel shrapnel and pulverized rock tears through the air. A piece of fragmentation the size of a man's thumb severs a hydraulic line on a bulldozer. High-pressure fluid sprays over the hot engine block. The machine dies. There is no mechanic's bay to retreat to. There is no safe rear echelon. The Seabee mechanics sprint from their foxholes carrying heavy tool bags. They dive under the paralyzed bulldozer while mortar shells continue to fall. They lie in the 140-degree dirt. They bleed from the ears from the concussive overpressure of the bombardment. They strip the damaged hydraulic line. They jury-rig a replacement using salvaged copper tubing and heavy clamps. They cover the engine in grease. They restart the machine. The blade drops. The diesel roars. The earth moves. They do not retreat. They do not take cover. They do not stop. Step 3 is the surface. The compacted ash is still too fragile to support the massive, sustained friction of aircraft tires. The engineers must cap the runway with steel. They use Marston mat, officially known as pierced steel planking, or PSP. A single sheet of PSP is 10 feet long, 15 inches wide, and punched with rows of large circular holes to reduce weight and allow for drainage. It weighs 66 pounds, roughly the weight of an anvil. It is cumbersome. It is heavy. It absorbs the ambient heat of the sun and the geothermal heat of the ground until the steel is physically painful to touch, even through canvas gloves. The Seabees lay the steel by hand. They form massive, synchronized lines across the width of the runway. A truck slowly reverses, dropping bundles of the planking. 2 men grab a sheet. They lift the anvil. They carry it forward. They align the heavy steel hooks on the edge of the sheet with the slots on the previously laid row. They drop it. They swing heavy sledgehammers, violently driving the hooks into the slots to lock the steel matrix together. Clang. 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 They move to the next sheet. They lift, they align, they strike. They must lay tens of thousands of these sheets. They must construct a solid steel carpet measuring 5,000 feet long and 150 feet wide. They are building an industrial highway, by hand, piece by heavy piece, under a continuous rain of explosive artillery. The physical toll is absolute. Men collapse from heat exhaustion, their bodies violently rejecting the sulfur, the physical exertion, and the psychological terror. Medics drag the unconscious men into defilades, pour lukewarm, chemically treated water over their faces, and leave them. There is no evacuation. The line of steel must advance. A new man steps into the gap. He grabs the tongs. He lifts the 66-pound sheet. He swings the hammer. The runway slowly, violently pushes its way northward. It is an act of sheer, bleeding defiance. The Japanese gunners on the high ground watch the impossible unfold. They double their rate of fire. They concentrate their mortars on the leading edge of the steel matting. They shatter the freshly laid planks. They leave twisted, jagged craters of ruined steel and pulverized rock. The Seabees drag the destroyed steel away. They push new dirt into the new craters. They roll it. They cap it. They swing the hammers. It is a war of raw, mechanical attrition. The Japanese are betting their ammunition against the Seabees' blood and diesel. The greater operator does not look at the dead bodies being carried to the beach. He does not look at the sky. He watches the leading edge of his steel blade. He watches the volcanic ash curl and fold perfectly along the predetermined angle. He feels the deep, rhythmic vibration of the caterpillar engine vibrating through his boots. He breathes the toxic air. He controls the machine. He imposes human will upon the hostile earth. The runway is growing. The individual grit of a single Seabee swinging a sledgehammer is the micro-engine of the Pacific campaign. But a bomber base is not built by hand alone. A bomber base is an apex predator of heavy industry. It requires mass. It requires volume. It requires a logistical bloodline stretching continuously back to the steel mills of Pittsburgh and the oil refineries of Texas. To convert the shattered, unworkable pumice of Iwo Jima into a platform capable of handling the 20th Air Force, the United States Navy must import a mechanized city. Look at the offshore anchorage. The water is choked with the gray, slab-sided hulls of the amphibious supply fleet. From the deep water, flat-bottomed landing ship, tanks, vessels measuring 328 feet long, the length of a city block, drive their bows directly into the abrasive volcanic surf. The massive bow doors swing open like the jaws of steel leviathans. The payload is not infantry. The payload is infrastructure. They bring 15,000 tons of Marston matting, the structural steel equivalent of a heavy cruiser, shipped flat in dense, iron-strapped bundles. They bring 200,000 barrels of aviation-grade fuel, a volume of highly volatile liquid sufficient to fill a municipal reservoir, pumped through miles of flexible rubber hosing laid directly across the contested beaches. They bring heavy rock crushers. They bring motorized graders. They bring the massive, rotary kilns of diesel-fired asphalt plants. Every single piece of this industrial puzzle must be dragged through the soft, wheel-swallowing black sand of the beach, hauled up the steep, mortar-pounded terraces and driven directly into the kill zone of Motoyama. The pierced steel planking is the initial band-aid. It is sufficient to land a nimble 12,000-pound P-51 Mustang. But a Boeing B-29 Superfortress is a different physical entity. When a Superfortress touches down, its colossal weight is focused entirely on its dual-main landing gear tires. The localized downward pressure is catastrophic. If a B-29 lands on raw, pierced steel planking laid over loose ash, the steel will instantly buckle. The ash will shift. The bomber will violently cartwheel into a fireball of vaporized, high-octane aviation gas. A B-29 requires a runway that is absolutely rigid. It requires crushed aggregate. It requires binding. It requires asphalt. Directly parallel to the active runway, completely exposed to the jagged high ground of the northern plateau, the Seabees erect the asphalt plant. It is a towering, roaring monstrosity of iron and fire. It is an unmissable target. It bleeds thick, black smoke into the sky. Its diesel burners operate at 2,000 degrees Fahrenheit, the ambient temperature of a deep mantle magma chamber. The operation requires a flawless, uninterrupted loop of heavy transport. Dump trucks arrive at the beach, load blasted coral aggregate shipped in from the Mariana Islands, and grind in low gear up to the plant. The rock is fed into the roaring kilns, dried and violently mixed with boiling liquid bitumen. The steaming 300-degree asphalt is dumped into the waiting beds of specialized hauling trucks. The trucks drive to the active runway edge. The asphalt is laid. The heavy steel rollers compress it. The trucks return to the plant. It is a conveyor belt of civil engineering. If the belt stops, the operation dies. If an asphalt truck stalls, the 300-degree mixture inside its steel bed begins to cool. Within 30 minutes, it will harden into an immovable 10-ton block of concrete. The truck becomes a permanent, useless monument. The paving must not stop. The Japanese artillery mathematically dissects this conveyor belt. They do not aim for the infantry. They aim for the machinery. Shrapnel tears through the thin steel of a dump truck bed. The driver slumps over the steering wheel, bleeding out into the cabin. The truck veers off the grade. Within 90 seconds, another Seabee opens the passenger door. He unceremoniously pushes the casualty into the right seat, drops into the driver's side, grinds the transmission into first gear, and rejoins the loop. The casualty is an unfortunate statistic. The truck is essential. Then, the geology of the island launches its own devastating counterattack. It is 1,300 hours. The paving operation is advancing past the 2,000-foot mark. A 30-ton Caterpillar D8 bulldozer, the mass of a humpback whale, is meticulously reversing over a newly compacted section of the subgrade. The surface of Iwo Jima is a deceptive lie. It is not solid earth. It is a fragile crust resting on a hollow, subterranean honeycomb. 50 feet below the blade of the bulldozer lies a massive, multi-tiered Japanese command bunker, carved directly into the volcanic basalt by hand. The continuous rhythmic pounding of the heavy steel rollers and the sheer, localized weight of the heavy machinery has mathematically compromised the structural integrity of the cavern's ceiling. The warning is non-existent. There is no sound. There is only a sudden, catastrophic failure of physics. The operator feels the deep vibration of his diesel engine suddenly alter pitch. The ground directly beneath his steel tracks does not compress. It evaporates. The crust shatters. A ragged void, 40 feet across, instantly rips open in the center of the active runway. The bulldozer tilts backward. The machine groans as gravity violently claims it. 30 tons of iron, diesel, and humanity plunge backward into the darkness. A massive plume of ancient sulfurous dust and pulverized rock erupts from the newly formed crater, rolling over the adjacent paving crews. The runway is completely severed. The asphalt trucks slam on their brakes. The conveyor belt stops. The crisis is absolute. But the hole is not empty. The collapsed cavern connects to the active, sprawling network of Japanese defensive tunnels. The violent intrusion of the bulldozer has breached the enemy's subterranean fortress. Before the dust plume can even settle, the sharp, rhythmic, high-velocity crack of Arisaka Type 99 rifles echoes out of the abyss. Japanese infantrymen surviving in the darkness below are firing straight up through the crater directly into the bellies of the halted asphalt trucks. A Seabee standing on the running board of a grader takes a 7.7 millimeter round through the collarbone and falls into the hot ash. The engineering column is paralyzed. They are sitting atop hundreds of gallons of boiling asphalt and highly flammable diesel fuel, receiving accurate small arms fire from an entrenched subterranean enemy. The standard military doctrine dictates falling back. It dictates calling in an infantry sweep. It dictates waiting for explosives experts to clear the tunnel network room by bloody room. The Seabees do not have time for standard military doctrine. The asphalt in the truck beds is cooling. The B-29s in the Marianas are already taking off. A heavy equipment foreman assesses the geometry of the disaster. He looks into the 40-foot crater. The D-8 bulldozer is a mangled, smoking ruin of steel at the bottom of the cavern. The operator is gone, crushed instantly within the iron cage of his own machine. His tomb is already excavated. His burial is a cold, mechanical necessity. The foreman signals the heavy equipment operators. The solution is not tactical. The solution is strictly, brutally industrial. 2 armored D-8 bulldozers rumble out of the staging area. They do not send men with rifles to the lip of the crater. They drop their heavy steel blades. The bulldozers engage the massive piles of displaced volcanic rock at the edge of the runway. The engines roar, screaming against the governor. They push a massive wave of boulders, loose ash, and pulverized debris directly toward the open breach. The Japanese rifles continue to fire from the darkness. Bullets spark and shatter against the heavy steel dozer blades. The operators do not flinch. They do not stop. They push the wall of earth over the lip of the crater. Hundreds of tons of aggregate pour into the void. It cascades over the shattered bulldozer. It cascades into the tunnel arteries. It violently buries the Japanese infantrymen where they stand. It buries the sniper fire. It buries the wreckage. It buries the fallen American operator in a heavy, inescapable tomb of volcanic rock. The bulldozers reverse. They push another load, and another. They aggressively fill the cavern until the black ash is level with the surrounding grade. Immediately, the heavy steel drum rollers advance. They drive directly over the fresh mass grave. They vibrate. They crush the air out of the loose rock. They aggressively compact the earth, rendering the subterranean tunnels permanently sealed. The foreman checks his watch. 14 minutes have elapsed. The foreman waves his arm in a wind, sweeping arc. The halted asphalt trucks release their brakes. They grind into gear. The first truck backs up to the newly compacted scar in the earth. The hydraulic bed lifts. 300 degrees of steaming black tar pours directly over the buried wreckage, sealing the crater beneath a flawless, impenetrable sheet of industrial asphalt. The loop resumes. The rollers track back and forth. The toxic, black smoke of the plant continues to rise into the humid Pacific air. The obstacle has been violently assimilated into the foundation of the runway. The industrial machine does not mourn. It paves. March 4th, 1945. The asphalt of Motoyama Airfield No. 1 is still radiating chemical heat. The air is still thick with the smell of vaporized bitumen and sulfur. The artillery shells continue to fall on the northern perimeter, but the geometry of the runway is complete. 3,000 feet of solid, unyielding blacktop cuts a perfect mathematical line through the chaotic ruin of the island. It is an industrial dagger plunged directly into the heart of the Japanese defensive network. High above the Philippine Sea, a Boeing B-29 Superfortress is dying. The bomber, christened Dynamite, is returning from a deep penetration strike over Tokyo. It is a bleeding Leviathan. It weighs 133,000 pounds, the equivalent mass of a heavily armored naval patrol boat, and it is falling out of the sky. The fuel tanks are ruptured. The primary hydraulic lines are severed. One of the massive right radial engines is dead. feathered and useless. Another engine is violently vibrating, tearing itself apart from the inside, spitting hot oil over the aluminum cowling. The pilot fights the heavy yoke. He feels the sluggish dying momentum of the machine. The navigator calculates the remaining distance to the Marianas. The mathematics are cold. The mathematics are absolute. They are hundreds of miles short. Beneath them is the Pacific Ocean. It is a cold, churning abyss. Ditching a crippled B-29 in heavy swells is not a landing. It is a violent kinetic disassembly. The fuselage will shatter. The glass nose will crush. The 11 men inside will drown in the dark. Then the radio operator catches a signal. It is a beacon. It is a vector pointing toward an 8-square-mile extrusion of volcanic rock. The pilot pushes the nose down. Through the cracked plexiglass of the cockpit, he sees the smoking, shattered mass of Iwo Jima, and slicing through the center of that hellscape, he sees the black ribbon of Motoyama. He does not know that the runway beneath him is built over a mass grave of pulverized Japanese bunkers and a crushed American bulldozer. He does not know about the sledgehammers, the blistering heat, or the sniper fire. He only knows that the geometry is perfect. The B-29 descends. The landing gear deploys with a heavy mechanical thud. The pilot cuts the remaining throttles. The massive machine drops. This is the ultimate test of the Seabees' brutal engineering. When the dual main tires of the superfortress slam into the tarmac at 130 miles per hour, they deliver a localized kinetic shock wave equivalent to dropping a solid block of cast iron from a 3-story building directly onto the pavement. If the subgrade is soft, if the compaction is flawed, if the asphalt is too thin, the blacktop will instantly buckle. The gear will shear. The bomber will cartwheel. The rubber screams against the asphalt. A cloud of blue smoke erupts from the tires. The shockwave transfers from the landing gear, through the tarmac, and deep into the crushed volcanic rock below. The ground holds. It does not shift. It does not buckle. The compressed aggregate absorbs the violent kinetic energy of the failing bomber. The brakes squeal. The aircraft rolls past the craters, past the smoldering ruins of the Japanese fighter planes, and grinds to a halt at the end of the strip. The engines choke and die. 11 American aviators open the side hatches. They step out onto the hot, black asphalt. They are alive. They do not drown in the dark. They do not shatter against the swells. They do not die. They breathe the sulfurous air, standing on a miracle of raw industrial stubbornness. This single landing justifies the entire invasion. But the kinetic violence of Motoyama is only just beginning. The emergency landing of dynamite is not an isolated miracle. It is the opening of a massive industrial floodgate. In the weeks that follow, the sky bleeds heavy bombers. B-29s with shattered plexiglass noses, bombers with entire tail sections chewed away by anti-aircraft fire. Machines trailing massive plumes of thick black oil. They all limp toward the black slab of Motoyama. They come in on 3 engines. They come in on 2 engines. They come in entirely devoid of hydraulic fluid, relying on the sheer friction of the asphalt to arrest their massive momentum. Over 2,200 crippled superfortresses will utilize the airfields of Iwo Jima before the cessation of hostilities. 24,000 American aviators, the population of a small Midwestern city, will be spared a violent death in the cold Pacific waters. The asphalt laid by the Seabees under direct mortar fire becomes the busiest, most vital emergency ward in the history of aerial warfare. The island becomes a self-sustaining organism of violence. When the P-51 Mustangs of the 7th Fighter Command are not escorting the heavy bombers to Tokyo, they are unleashed upon the island itself. They launch from Motoyama, circle tightly, and immediately dive upon the remaining Japanese positions on the northern plateau. They drop 500-pound general-purpose bombs directly onto the cave entrances. They strafed the camouflaged artillery positions with thousands of rounds of incendiary ammunition. The very high ground that rained death upon the construction battalions is systematically dismantled by aircraft launching from the exact dirt the Japanese failed to hold. It is a perfectly closed loop of localized destruction. Then, the strategic bombers are unleashed without tether. For the first time in the war, the B-29s do not fly naked. When they approach the factories of Tokyo and Nagoya, the Japanese interceptors rise to meet them, expecting the usual slaughter of unescorted targets. Instead, they are met by a wall of American fighter aircraft launching directly from the new island base. The P-51s tear into the Japanese formations. They shred the twin-engine heavy fighters. They outmaneuver the nimble Zeros. The skies over the Empire are violently cleared. The strategic bombers drop their payloads with impunity. They incinerate the industrial hubs. They turn the manufacturing centers to ash. Deep beneath the surface of Iwo Jima, in his subterranean command bunker, Lieutenant General Tadamichi Kuribayashi hears the continuous, deafening roar of the heavy engines operating directly above his head. His mathematical calculation has failed. His strategy of attrition has been bulldozed by the sheer, unyielding weight of American logistics. He realizes, with cold, inescapable clarity, that the airfields he meticulously designed as a slaughterhouse have been fully weaponized against his homeland. The Japanese artillery still fires. The Seabees still die. The bulldozers still push the black ash. But the strategic paradigm has completely, permanently shifted. The Pacific Ocean is no longer a protective moat for the Japanese Empire. It is a paved highway. The bombers leave the Marianas. The fighters leave Iwo Jima. They rendezvous in the sky. They deliver absolute destruction. They return. They repair. They reload. The cycle of kinetic violence is unbroken. The base is operational. The war is won on the dirt. Look at the final, cold mathematics of Motoyama. Strip away the propaganda, strip away the myth. The declassified ledgers of the United States Navy do not record heroism. They record inventory. They record the absolute, unforgiving cost of doing business in the Pacific. The timeline of construction. The 133rd Naval Construction Battalion landed on D-Day, February 19th. By March 4th, just 13 days into a 36-day bloodbath, Airfield No. 1 was actively receiving heavy bombers. The Seabees paved a 3,000-foot highway under a continuous, unbroken barrage of Japanese 150mm howitzer fire. The material expenditure. The engineers laid down 15,000 tons of pierced steel planking. That is the exact displacement weight of a fully loaded Brooklyn-class light cruiser, unspooled entirely by hand, sheet by heavy 66-pound sheet, across a live battlefield. They poured thousands of tons of boiling asphalt, a volume sufficient to pave a 2-lane civilian highway from Washington, D.C. to Baltimore, directly over active, subterranean enemy fortifications. The human cost. The 133rd Seabees suffered 328 casualties. That is over 40% of their entire battalion's strength, a staggering attrition rate mirroring the frontline Marine infantry they supported. Across the 8-square-mile island, 6,800 Americans bled to death in the black ash. The population of a thriving Midwestern farming town permanently erased. Conversely, Lieutenant General Kuribayashi's garrison of 21,000 men was structurally annihilated. They were starved, burned, and buried alive in their caves. A population equal to a sold-out Madison Square Garden, entombed entirely within the volcanic basalt. Fast forward to the present day. Look at the coordinates 24.78 degrees north, 141.32 degrees east. Iwo Jima is no longer a strategic fulcrum. It is a ghost ship anchored in the Philippine Sea. The island has been returned to the Japanese government. It operates strictly as a highly restricted base for the Japan Maritime Self-Defense Force. There are no civilian settlements. There are no commercial flights. There are no tourists. The geothermal vents still bleed toxic yellow sulfur into the 95-degree air. The black ash still violently swallows the boots of the few maintenance crews who walk the perimeter. The original, violent geometry of Motoyama Airfield No. 1 is still visible. The asphalt laid by the bleeding bulldozers of the 133rd has been overlaid with modern concrete, but the exact footprint remains identical. It is an enduring scar on the face of the earth. Beneath that runway, beneath the modern military cargo planes that occasionally touch down, the subterranean architecture of Tadamichi Kuribayashi still exists. The tunnels are collapsed. The caves are permanently sealed. But the thousands of entombed Japanese soldiers remain exactly where the American heavy machinery buried them. They are part of the island's foundation. They are the subgrade of the modern runway. This is the ultimate unvarnished truth of industrial warfare. We romanticize the infantryman. We build towering marble monuments to the fighter ace. We write extensive poetry about the grand strategies of generals. But the machinery of global conflict does not operate on courage. It operates on logistics. It operates on the ruthless, mechanical capacity to displace earth, pour concrete, and manufacture steel faster than the enemy can destroy it. Iwo Jima was not conquered by tactical brilliance. It was conquered by brute force engineering. It was defeated by blue-collar men with receding hairlines who understood that war is simply a violent construction site. They did not merely outfight the Japanese Empire, they outbuilt them. They looked at a mathematically perfect, impregnable fortress designed exclusively to bleed them dry, and they answered it with screaming diesel engines, heavy sledgehammers, and boiling asphalt. They weaponized civil engineering. They turned the ground itself into the ultimate instrument of strategic destruction. The Pacific War was won because the United States military realized a fundamental truth. A man with a rifle can hold a line, but a man with a 30-ton Caterpillar D8 bulldozer can move the line entirely. The equation is cold. The equation is mechanical. The equation is absolute. Blood buys the dirt, but heavy machinery buys the victory. Today, the Pacific wind howls across the desolate, flat expanse of Motoyama. It blows the loose black sand over the concrete. It whistles through the rusted, forgotten shards of steel shrapnel still half buried in the pumice. The island remains silent, save for the grinding hiss of volcanic ash violently erasing its own history.